This is a review for exam 1. Let's begin. Number 1, it says that the molecular geometry of nitrogen monoxide NO is linear. The answer is true because if you draw the Lewis structure of NO, that will be the Lewis structure, okay, and it's linear. Okay, so question 1 is true. How many valence electrons are in nitrogen atom? The answer is 5, because if you look at your periodic table, you will see that nitrogen is on main group 5. 1, 2, skip all these, 3, 4, 5. So the answer is 5. Okay, valency of 5. What is the total number of valence electrons in that structure? So it's simple. Again, use your periodic table. Carbon is on main group 4. If you forgot, we just count the columns 1, 2, 3, 4. Do the same for the rest. Okay, there are 2 of them, so those 2 carbons are contributing 8 valent electrons, and then you have an oxygen. Oxygen is on main group 6. It brings a valency of 6 electrons. Nitrogen, like we said, is on main group 5, and then you have 5 hydrogen. Each hydrogen has a valency of 1, 4, 5. Okay, so what will be the answer? So it's 14 and 10. The answer is 24 valent electrons. 8 from the carbons. Okay, 8 from the carbons. 6 from the oxygen, that makes 14. 5 from the nitrogen, 19, and then plus 5 you get 24. Okay, what is the formal charge on nitrogen? What's the formal charge on nitrogen and the carbon atoms in the structure below? So formal charge calculations, we have this structure right here. I think that's question 4. Remember the formula? It's simple. Formal charge equals to number of electrons on the element, on the free element on the period, number of valent electrons on free element on the periodic table. So let me just say valence electrons. Okay, so you need the number of valence electrons like we did here on the free element, and then you'll subtract any non-bonding electrons, and then subtract the number of bonds around the central atom. So if you're looking at the carbon, so Fc of the carbon will be equal to, the valence of carbon is 4. Okay, and then there's no lone pair shown, so no non-bonding electrons. And then how many bonds around the carbon? 3. So the charge on the carbon is +1, not 1, it's +1. Do the same thing. The formal charge on the nitrogen will be equal to, valency of nitrogen is 5 on the periodic table. There's no non-bonding electrons there, and then there is 4 bonds around the nitrogen, so it's +1. So both of them are plus. Unlikely, but that would have been the answer. Which of the following have dipole moments strongly marked? Select all that apply. Alright, so let's see where is our periodic table. So electronegativity increases across the periodic table, and the dipole moments points the most electronegative element. So hydrogen and sulfur, sulfur is to the right, A is correct. Hydrogen and chlorine, Chlorine is to the right of hydrogen. That's correct. Nitrogen and sulfur. Nitrogen and sulfur. Which one is more electronegative? Electronegativity also increases up the periodic table. Okay. So it's saying here that sulfur is more electronegative. Nitrogen is on top of silicon. Okay. This is nitrogen silicon, not nitrogen sulfur. Nitrogen and silicon. Nitrogen is on top of silicon, so that applies. Electronegativity increases up, and nitrogen is to the right. So that's correct. This is wrong. Sorry. The arrow should be pointing nitrogen, and then B and O. Oxygen is more electronegative than boron, so that's correct. So the answer here should be C. Okay. Next. Which of the following molecules have 4 electron domains around the central atom? Select all that apply. For this question, you need to draw the Lewis structures. So if you draw the Lewis structure of ammonia, that's how it is. If you draw the Lewis structure of the next one, we did it when we were lecturing. That will be the structure of B. So this is your A, this is your B, according to what I'm looking at. And then for dihydride sulfide, this will be the Lewis structure. And then for sulfur dioxide, it's a neutral molecule, that will be the Lewis structure. Okay. So which one has 4 electron domains? Remember, for review, an electron domain can be a lone pair. Okay. An electron domain can be a single bond, or can be a double bond, or a triple bond. At least according to Survey Organic, that's where we stop. There are more definitions. So around this nitrogen are 4 electron domains. So that's one of them. On the formaldehyde, I only have 3 electron domains. So that's not it. On the dihydrogen sulfide, I have 4 electron domains. Okay, that's one of them. And then around the central atom of sulfur, I have 2 electron domains. That's out. So the answer is A and C only. Use NF3 to answer the set of questions below. Okay, so we are looking at NF3, nitrogen trifluoride. The Lewis structure should be like this. That's how you need to start answering the question. Draw the Lewis structure showing all possible electrons. Okay, what is the molecular geometry? Molecular geometry, we consider only the atoms connections. So I don't care about the lone pairs. So if I connect all these guys, I find that the molecular geometry has a these 3 base elements, so it's trigonal. The base has 3 sides, and then looks like a pyramids of Egypt. So it's trigonal pyramidal. That's the Mg. Now the central atom has a lone pair, so the Mg will be different from Eg. See, the electronic geometry here would have been tetrahedral, but I don't think we're asked. So let's see what's the electronic geometry. It's asked, so it's tetrahedral. So the Eg is gonna be tetrahedral. Why? Because now we consider the electron domains around the central atoms. If you connect them, it's gonna look like this, and if you connect the sides, including the central part, it's gonna be tetrahedral. For electronic geometry, it's different from Mg because the central atom has a lone pair. Now, what is the hybridization? Hybridization goes with electron geometry. So if the Eg is tetrahedral, we definitely know that hybridization is sp3 because you see the circled parts, you have 4 electron domains. So 4 electron domains help you to know that it's sp3 because you have an 1s and 3 p's. Okay. Alright, so next, what's the approximate bond angle? I told you when it's tetrahedral, approximate bond angle should be approximately 109.5. Okay. And then we've answered the electronic geometry. Is NFP polar or non-polar? It has to be polar because you have the electronegative fluorines at an angle. Dipole moments point downwards. So you have a net dipole moments pointing downwards. So yeah, it's polar. So by now you see the answer. Cannot be B, C, D, or F. The answer is A or E. Okay, trigonal planar sp2, nope. So the answer should be E. It follows all that I've listed here. Okay, next. This drug conalapri is used to treat high blood pressure. The structure is shown below. A. What is the molecular geometry of atom labeled C? Okay, so C, where C is, there must be a hydrogen on there. So you needed to, I'm just gonna say the rest of the structures are, because I don't want to waste time drawing the whole quinanoprene drug. So on C there's a hydrogen. Okay, that's why it points C. Yeah. This is your C right there. So I see that I have three well, you don't need the electron domains, but anyway, we have 3 electron domains. But again, what I want to say is that the molecular geometry, you connect the atoms. I thought it was electronic geometry, that's why I'm talking about domains. But molecular geometry, all you do is to connect the atoms. And because there is a double bond there, I gave you the shortcut in class and told you it must be planar. It's planar, but you're connecting outside, you're connecting 3 elements, so it's trigonal. So Mg on C is trigonal planar. There's no lone pair, so Eg will also be trigonal planar because there's no lone pair on the carbon C, marked C. Okay, what is the immediate resonance structure for this one? Now I think I will have to delete this. So we start over. So we are asked on the immediate resonances. So you start from either the lone pair or the double bond to do resonances. If the lone pair is provided, you start from the lone pair. So if you push this way, okay, let me just draw the bonds the way they are in the ring in the question. If you make a pi bond there, this will give way, pushing the electrons here. So you make a carbonyl, you're left with 2 lone pairs after using 1 to make the pi bond, and then you are left with a lone pair next door with a negative charge. If you do your formal charge calculations, there's gonna be a negative charge. So which is the answer? It looks like the answer is resonance structure B, not D. D is not showing the formal charge, that's why it's wrong. So it's resonance structure B. Which of the following is or are not the correct way of pushing arrows in resonance? Okay, this is correct. So the first one is correct. Let's look at A. So you push towards the side where there's less electrons, so which is this way. The immediate resonance structure you get is gonna be that. And now the plus sign will go behind because now this CH2 right here is 1 bond less. Okay, so A is correct. What about B? So for B, B is wrong because I told you you want to start from the lone pair if the lone pair is provided. You want to go this way, okay, not the way it's shown on here. That's wrong. Okay, we are asked which one is not correct, so resonance B. Okay, it's one of them, and then C is wrong because this is not a resonance, this is a shift. Okay, and then this is wrong because again you're breaking a sigma bond, not a pi. This is breaking a sigma bond, breaking a sigma bond, so C and D are wrong. The only correct arrow pushing is gonna be A. What intermolecular force of attraction would exist between two molecules of propane? Now if you look at propane is all a hydrocarbon. So let me see, I drew the wrong structure. It's 3-carbon structure. It's carbon and hydrogen. So if you bring another molecule, carbon or hydrogen, there's no electronegative element. So all that you have in hydrocarbons, like we said in the lecture, hydrocarbons will always have the London dispersion forces, otherwise called weak van der Waals forces. How many carbon atoms are in the structure below? Alright, so there's 5 carbons in the ring. There's a carbon here, that makes 6. There's a carbon here, 7, and then there's a carbon here, 8. What factor below helps stabilize the carbocation? If you've forgotten what the carbocation is, it's a carbon with a plus charge. Okay, so size does not apply. Electrophilicity, that's not even considered. Nucleophilicity is not a nucleophile anyway. It has to be inductive effect because that's the term we used when we say that the R groups will be donating electrons through bond. Those electrons will help to neutralize the C plus center because electrons are negatively charged. Okay, so the answer is D. Name the following compound. So let's draw the compound. We need to give the IUPAC name. Up, down, up, down, up, down, up. And then I think I drew it correctly. So the first step is to identify the longest chain. I can go 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8, 9. So looks like the longest chain should be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 in red, or 1, let me use a different color. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are going to take this whole thing as a substituent and this as a substituent. So if you go with the blue, you have a substituent on 4, 5. Sum it up, you get 9. If you go with the red, you have a substituent on 5, 6. Sum it up, you get 11. So the red numbering is wrong because it's not prioritizing the substituents. We said you have to give the substituents the lowest locant position possible. Okay, so we go with the blue because it's when you add 4 and 5 and add 4 and 5 you get 9, which is less than 11. So the name will be written following alphabetical rule. That's this is not an F. I think this is a propel. That's a propel, and this is a methyl. Okay, so we have M and P. MNOP. M comes before P. So the name will be 4-methyl 5-propyl, and then 9 carbons on longest chain, no, NEN, MNOP. So the answer is A. Okay. You can pause the video, rewind if you want to check my explanation, but I'm gonna delete again. I want to use the page. So for the next one, we are asked to name this molecule. Okay, I believe that's the structure. Because it's an alkene, we give the double bond the lowest number possible. We have to start from the left, not the right. 3, 4, 5, 6, and 7. The CH3 is a substituent. So the substituent is our it's a methyl group. Okay, and now we know that we have 7 carbons. The longest chain contains the double bond, so it's 2-heptene. Otherwise, someone else will call it hept2-ene is still okay. Hept2-ene, where 2 defines the position of the double bond. You have a methyl on carbon 4, so it's 4-methyl. Separate the numbers and alphabets with hyphens. So 4-methyl 2-heptene, or alternatively, it will be correct if it's 4-methyl hept2-ene with no space between L and H. Okay. So you already see the answer here. So it should be 4-methyl 2-heptene, which is what I got right there. 4-methyl 2-heptene. Next, what's the IUPAC name of the alkyne which has this structure? I'm gonna show the carbons in the triple bond. That's the catch. So here we prioritize the position of the triple bond, so I have to start from the right. 1, 2, 3, 4, 5, and then when I get here, I have to maximize the substituents. So I have to make sure I have maximum substituents. So if I go 6, 7, then I'll only have one substituent that's a proper. But if I go 5, 6, 7, then I have this as a substituent and I have that as a substituent. So you want to have more substituents rather than few. So that's the correct route of going. When you get to 5, that's a methyl, this is an ethyl. So the name will be, the name is simple, it's gonna be 5-ethyl, because E comes before M, and then 6-methyl, okay, and then of course we have the first alkyne carbon at 3, and then 7 carbons, so it's heptine. Okay, 5-ethyl, 6-methyl, 3-heptine. Okay, moving on. Taxol is an anti-cancer drug used in chemotherapy. It's found in plants, so it's a plant alkaloid. What is the identity of the functional groups A through D in that order? So A is an amide. Okay, we said amides will have this general structure. R could be H or carbons. A is an amide, and then B, obviously B is an alcohol. ROH, that's an alcohol. And then C is an ester, because I see a metal, there's a carbon in the metal, and then there's an oxygen, there's another carbon, that's an ester functional group. And then lastly, D, I see a carbon to an oxygen, the oxygen to a carbon. That's called an ether. So what is the answer? Amide, alcohol, ester, ether. So the answer is the last one. How many transition states are in the profile diagram? The transition state is the highest point. So we only have one transition state in this energy diagram. Here is the product, activation energy, heat of reaction, okay, and then we have the product right there. So the transition state is Y, the highest point, the highest point of the mountain or the hill is the transition state. So we only have one. Intermediates, there is no intermediates. If you had intermediates, then you'll have the first activation energy, second activation energy. The intermediate will be right here. Just like if you have a dromedary camel, which has 2 humps. I'm not good in drawing, but at least you understand what I mean. If this is your camel, where you sit, that will be your intermediate. So in this energy diagram, that's the intermediate. That's where carbocations dwell mostly. So there's no intermediate. Which alphabet represents heat of reaction? It's gonna be C. The difference in energy, potential energy between the reactants W and the products Z is the heat of reaction. When drawing a mechanism, the arrow can be drawn from a positive center to a negative. I said already when we started that you start from a negative to the side where there's less electrons. So this is false. You don't start an arrow from positive to negative, it's the other way around. Why is CO2 not soluble in water? Okay, so in that question you will have to draw, you are supposed to draw the Lewis structure, and then you'll notice that the dipole moments will cancel. So CO2 is nonpolar because the dipoles are pointing on direct opposite direction, not at an angle. So the dipoles are canceling. So CO2 turns out to be nonpolar. Now what about water? The Lewis structure of water, you will have the hydrogens at an angle, dipole moments pointing towards the more electronegative oxygen. So this net dipole moment pointing up. So we know that water is polar. But there's a rule that we said like dissolves like dissolves like. Are these like? Nope, they are not like. They are alike, alike, yeah. They are not same. One is polar, one's non-polar. So that's why CO2 does not dissolve. So you say because CO2 is a non-polar molecule, water is a polar molecule. That's the answer. What's the IUPAC name of the structure below? We proceed with the structure. It's an alkene again. You have a methyl group here. I think I need to keep going. You have another methyl group here. 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, again we prioritize our double bond. So we start numbering from the left. 2, 3, 4, 5, 6, 7, 8, 9. So it's a nonene. So the C choice is out. That's an octene. And I see that I have a metal on 4 and a metal on 8. So it should be 4,8 di because we have 2 metals. 4,8 dimethyl. And then the double bond is on carbon 2, 2 nonene. So the answer is D. Moving on. What's the IUPAC name for this structure below? I have to delete again all this so we can start over. Okay, down, up, down, up, down, up, down, up, down, up, and then isoproper is right there. I think. Okay, so find the longest chain. I feel like the longest chain will be this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 6, 7, 8, 9, 10, 11. Okay. Alternatively, one will number it this way in red. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Of course, there are other numberings, but these are the two most close numberings. So if you go with the green, notice that you'll only have the isopropyl and the propyl as substituents. But if you go with the red, then you'll have your CH3 right there as a substituent. This will be a substituent, okay, and then the ethyl will be your substituent going with the red, and then the propyl will be your substituent. So going the red numbering, you have 3 substituents, the CH3 here, which I think I cannot write there, can I? Yes, I can. So you have the CH3 right there, that will be a substituent. You have the ethyl, so you'll have your methyl, you'll have your ethyl, and you have your propyl. But if you go with the green, you'll have the isopropyl. Isopropyl is this piece that looks like a Y. Okay, you'll have the isopropyl and the propyl going with the green chain. So that would be wrong. So we want to go with the red because it gives us more substituents in our name. Okay, we talked about that before. So let's go with the red. So you have a methyl on 2 and ethyl on 3. So we go with the E, ethyl, and then M comes before P, so it's 2 methyl, and then you have propyl on 6, so 6 propyl, and then of course you have 11 carbon, so it's un decan. Undecan. That will be the IUPAC name. What's the hybridization of the atom labeled A? So again, there's a hydrogen there, is just not shown. I'm not going to draw the whole structure. There's a hydrogen here. Let me just call the rest of the structure R. So I have 3 electron domains. For hybridization, look at the electron domains. I have 3 electron domains, and we have the sp, sp2, sp3. So the sp2 has 1s and 2p's. Those are 3 electron domains. So that's an sp2 carbon center. Benadryl is a brand name for a number of different antihistamine medications used to stop allergies. What is the hybridization of the atom labeled B? So you're looking at the oxygen. You know the oxygen has no charge right now. So I'm just gonna call the rest R's. So we are looking at this oxygen B. This one. So there must be 2 lone pairs. Why? Because it has to be octet. You have 2 bonds, meaning you have 4 electrons. You draw the missing, the implied electrons, which makes 2 lone pairs. So on the oxygen, I have not 3. On the oxygen, I have 4 electron domains. Okay, so if I have 4 electron domains and I'm looking for hybridization, it has to be sp3, because sp3 has 1s, p, p, p. Those are 4 electron domains in the hybridization. So it's sp3 for the oxygen, not sp. Most students are saying sp, just counting the 2 bonds. You have to show the 2 lone pair of electrons. How many hydrogen atoms are in the structure below? Okay, now with this one I have to draw it out completely. This is one of those questions that was poorly done. Okay, so you need 4 bonds on this carbon. There's an implied hydrogen. You need 4 bonds on this carbon. There are 2 implied hydrogens. You need 4 bonds here. There are 2 hydrogens. You need 4 bonds here. There's 1 hydrogen implied. There's need to show 1 here. You need to show 1 here. Count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 hydrogens on this structure. 1, 2, 3, 3 plus 4, 7, 8, 9. Yeah, there are 9. What is the correct expected product for the reaction? Here you're just adding hydrogens across the pi bonds to kill the pi bonds. So the reaction is hydrogenation. Okay, so it's hydrogenation where the double bonds will be saturated with hydrogens. This molecule right here is said to be unsaturated. It's missing some of the hydrogens because of the double bonds. So if you're adding hydrogen gas in the presence of a metal catalyst like platinum or palladium, whatever it is, it says excess, which means it should react with all double bonds possible. You see here you have a CH2. So once the reaction is done, okay, let me bring this back to black. Once the reaction is done, you still have your CH2 there, but you're gonna add a hydrogen atom across the double bond. So hydrogen will go there, hydrogen will go there, hydrogen will go here, hydrogen will go here, because you're adding across the double bonds. It said excess, so hydrogen goes everywhere where the pi bond was. You kill the pi bonds. So this structure can be drawn without showing the hydrogens to look like this. That's how it will look. And which option is that? Choice. I can see it's choice A. Okay, it's choice A. Here you add the BRs across the double bonds, you lose the pi, so the answer should be choice A. No, not choice A, because you have to keep the metal, so the answer should be choice C. Tricky. Choice C, because all you're doing is adding BR across the pi bond, losing the pi. What is the correct product? Here we have to draw the mechanism. Let me show you. You have to draw a little mechanism. So for this one, you are adding first of all, the mechanism is catalyzed by an acid. So you're making a carbocation intermediate. Remember, we say that the hydrogen of the acid goes where there is more, according to Markovnikov addition, right? Let me clean up these things so they'll look nice. Okay, so this red hydrogen will go where there's more, which is down here, and then the plus sign will go up. So the hydrogen that's used in the mechanism goes where there's more, according to what we call Markovnikov addition. That helps you to give you the most stable carbocation, which this happens to be a tertiary carbocation, not third degree. We are not measuring angles. It's tertiary carbocation. Only then will the nucleophile come to attack. So in the mechanism now, the water will use the lone pair on oxygen to attack the carbocation. So you end up with your H2O here with your oxygen positively charged because you used one its lone pair. And like I said, you always do what we call proton transfer. Organic molecules don't like to be charged, so that happens when just another molecule of water is going to be used to steal a hydrogen from this positively charged oxygen, transferring the hydrogen to the water itself. So it's proton transfer. So the final product will be an OH sitting on the carbon structure. So this will be the final structure after Markovnikov addition. You will have converted your alkene, you will have converted your alkene to an alcohol. It happens to be a tertiary alcohol. So the answer here is choice C after Markovnikov addition. Alright, which is the correct product of the reaction below? This reaction is called Diels-Alder. It's a 4+2 cycloaddition. We said the dienophile is electron deficient. It's gonna have electron drawing groups. Obviously this is an ester. Right here, that's an ester functional group. Esters are electron drawing group because of the presence of a carbonyl. We said that during lecture. So anyway, you want to label these atoms, carbon atoms 1, 2, 3, 4, 5, and 6. So assume carbon 6 is attached to carbon 1, and then you're moving your pi bond, making a new pi bond here, and then in turn this is shifted to make a bond between 4 and 5. So really the product here will be a 6-membered ring, and the 6-membered ring has a new bond between 2 and 3, a new bond between 1 and 6. I'm drawing it in red because those are the arrows in red, and then a new bond between 4 and 5. Okay, and then all we need to do now is to copy the substituent that was the ester here, otherwise just written as COOCH3. Okay, so what is the answer? Looking at what we have here, the answer is choice A. Already, which is the correct product for the reaction below? This is hydrogenation of the alkynes. We have Lindlar's. We say the Lindlar's catalyst is not strong enough to reduce the alkyne all the way to alkane, so it reduces it to alkene and stops there and gives you the Z isomer. I've shown the carbons here so you know there are carbons in here. So 1, 2, 3, 4, 5, 6. So the structure should be, now these carbons will have the hydrogen added on the same side. So you lost one of the pi bonds here when you use hydrogen gas and the poisoned mild Lindlar's catalyst. So if this was just hydrogen gas, this next pi bond will go. For example, if this was just H2PD, all we'll have is an alkane. This is alkyne. It's reduced to the Z alkene. Okay, partial reduction. So answer is B. 1, 2, 3, 4, 5, 6. What step of the radical mechanism is this? You see you have two radicals. Because you have two radicals combining, if you combine these two guys using half arrows because you're moving one electrons, what you'll get is a structure, one structure which is not a radical. So this is termination. Remember what we said with termination? No new radicals formed, and you're combining two radicals. So that will be the answer. Okay, so that was your quiz. That was your exam 1 review. As you can see, we got everything right.